Hello, welcome to General Chemistry Lectures. My name is Lakshmaya Srirama. I am a professor of chemistry at Qatar University. I am mainly responsible for the delivery of this course to you. In addition to my own lectures, you will also hear lectures from Professor John Kwok as well as Dr. Yasir Hussain. With that introduction, let's begin these lectures. The lectures are organized into modules and submodules. The modules are based on the chapters in the prescribed book. For example, Chapter 1 will be Module 1, and this module is further subdivided into smaller lectures. In Chapter 1, we will summarize what is chemistry and observations, which are really nothing but measurements. We'll combine these two topics and make one lecture. So that will be part 1 of Chapter 1 or Module 1. Then there will be a second lecture on how to handle numbers. So that will be part 2. And there will be a third lecture on dimensional analysis and solving problems. That will be part 3. So let's ask the question, what is chemistry? If you think about it, it truly is all about study of matter and its properties. So what is matter then? Matter is anything that has a mass and occupies a space. Matter undergoes change, and therefore its properties change as well. So that means that chemistry subject is all about study of matter and the changes it undergoes. So I hope you get an idea for the definition of what is chemistry. So the study of the subject chemistry is considered difficult. Why is it? There are two reasons that come to my mind as to why students feel chemistry is difficult. One is that the field of chemistry has specialized vocabulary. So in other words, it is as good as learning a new language. The second reason why students feel chemistry is difficult is because the study of chemistry is all about making observations. These observations can be macroscopic and microscopic. Let's take an example. If you look at the bunch of nails in this picture, you can see that they are rusted. So in other words, nails made of iron rust when exposed to air. It is a macroscopic observation. However, what exactly is happening when rust formation happens is fascinating. Iron atoms will react with oxygen molecules to produce iron oxide as shown in this equation. This is a microscopic observation, and this microscopic observation is not easily apparent to the eye. Therefore, we need to derive these microscopic conclusions as to how it happens by making measurements. Because this is not very obvious, that is the microscopic observations, we will have to rely on mathematical calculations, interpretation of the microscopic observations, and this makes chemistry to be challenging to students. But however, if you are going to be focused and try to understand observations better, the chemistry subject is no difficult than any other subject you love. So let's take a look at matter and its properties for a quick second. Matter is anything that has mass and occupies space, and we defined this before. Let's define it again. Matter is anything that has mass and occupies space. Matter can exist in mixtures. So this matter can be either uniform or it can be not so uniform. If it is it's not uniform, then it is a heterogeneous mixture. If it is a uniform mixture, then we call it a homogeneous mixture. Homogeneous mixture does not have variable. Does it have variable composition or does it not have variable composition? If it has variable composition, that means yes, it is a homogeneous mixture, generally considered as a solution. On the other hand, if it doesn't, rather it has uniform composition, we call that pure substance. Pure substances can be further divided into two groups, elements and compounds. So matter is simply mixture of substances. These mixtures can be homogeneous or heterogeneous. The homogeneous mixtures can be solutions or pure substances. The pure substances can be elements and compounds. Now let's start thinking about properties of matter. Substances are identified based on their properties. There are two types of properties: physical properties and chemical properties. Physical changes lead to the description of physical properties, whereas chemical changes lead to the description of chemical properties. A physical change will not result in alteration of chemical composition of any substance. It simply changes the physical state. Whereas a chemical change results in composition of a substance. So in other words, the changes that lead to composition change of a substance are considered chemical properties. The physical changes that does not alter the chemical composition are considered physical properties. Now that we identified the properties, it is important to note that properties of substances can be measured. Now before we get into the measurement of properties, let's think about all measurable properties can be divided into two categories. All measurable properties can be divided into two categories. These categories include intensive properties and extensive properties. Intensive properties are dependent on how much matter is being considered. For example, mass of it, volume of it, and so on. Extensive properties, on the other hand, are independent of how much matter is considered. A good property of matter that falls in the extensive properties are density. So now that you know the two different types of measurable properties, let's think about measurements and units. To make any measurement, whether it is macroscopic or microscopic, we use instruments. These instruments can be used to make measurements that can be of macroscopic, which you can see directly, or microscopic. For example, a balance is used to measure mass. A meter stick can be used to measure length. A burette, a pipette, a graduated cylinder, and a volumetric flask can be used to measure volume. So here is a meter stick that we use to measure length, a balance that can be used to measure mass, and a burette, a pipette, a graduated cylinder, and a volumetric flask that can be used to measure volumes. Now let's think about microscopic properties. Microscopic properties at the atomic and or molecular scale must be determined by indirect methods. You cannot directly measure them. So this is where I was describing to you why chemistry becomes challenging. Now when we make measurements, all measurements are written as a number with an appropriate unit. Say take for example, body temperature is 37 degrees Celsius. Notice 37 is the number and the unit is degrees Celsius. So the units really indicate their magnitude on a certain scale. International system of units are used to make measurements, particularly scientific measurements. After 1960, this system of units came into existence. The International System of Units is based on the metric system. It is slightly modified from the metric system, and it is based on 7 base units. The 7 base units are listed in this table, which include length, mass, time, current, temperature, amount of substance, luminosity, in other words, the brightness of light. The units used are meter for length, kilogram for mass, seconds for time, amperes for electrical current, kelvins for temperature measurements, mole is the amount of substance, candela for the measurement of luminous intensity, and the symbols for each of them are also listed in it. It is important that you learn these base quantities, the unit and the symbol for each of them. When we make measurements, these measurements can be really large and can be very small. So take for example, say 12 grams of carbon contains this many atoms in it. If you really rewrite that using scientific notation, it is 6.022 times 10 to the 23 atoms. It's a large number. On the other hand, if you take a single carbon atom and weigh it, its mass is starting from this many zeros 119 grams. So really, if you write it in scientific notation, it is 1.99 times 10 to the negative 23 grams. So because we have these measurements that can be large and small, SI system units utilizes prefixes. The measurements that can be made, which can be small or large, can be modified using prefixes. These prefixes essentially indicate the magnitude of these measurements. So prefixes are therefore a way used to express magnitude of measurements. So let's take for example kilogram. A kilogram means that it is 1000 grams. Kilo represents 1000. Deci is 1/10 of it. Centi is 1/100th of it. Milli is 1000th of it. Micro is 1/1,000,000th. Nano is 1 times 10 to the negative 9th of it, and so on. With the example as a meter, how these prefixes transcend is indicated in this table. So, therefore, I suggest that you should know this table in particular. What are the prefixes? What are their symbols? What is the meaning? In other words, what is their magnitude must be learned. Okay, now having said that, let's look at one of the commonly encountered measurements that we make. That is mass. Mass is a measure of quantity of matter. The SI unit for mass is kilogram. That is 1 kg is equal to 1000 grams or equal to 1 times 10 to the 3 grams. We in the laboratory use these smaller units of grams rather than using kilograms. Now many times we come across the word weight. Weight is the force that gravity exerts on an object. So that means mass and weight are really different. So let's take for example weight is equal to C, which is gravity, times the mass. On Earth the gravity is equal to 1 and on Moon the gravity is 0.1. So that means 1 kilogram bar on Earth is 1 kilogram or really 1000 grams, whereas the same kilogram weighs 0.1 gram on the Moon. So we see the terms mass and weight are used interchangeably, but they do really mean different. Another unit that we come across is volume. Volume is the space occupied by a certain amount of substance. The SI unit for volume is meter cube. So SI unit for volume is meter cube. So that means that if you have an object, it is the three-dimensional space occupied by that substance. So you have a length, you have a width and a height. So if you multiply length times width times height, you get volume. So 1 centimeter cube really is equal to 1 centimeter times 1 centimeter times 1 centimeter. So that's equal to 1 centimeter cube. Remember, 1 meter cube or the meter cube is what is the SI unit for volume. Again, 1 meter is a really large space or a large volume. For practicality, we will use centimeter cubes. 1 centimeter cube is really equal to 1 times 10 to the negative 3 meter cube. So remember centi. Centi means 100th. That's why it is 10 to the negative 2. Which is really equal to 1 times 10 to the negative 6 meter cube. So 1 centimeter cube is really 1 times 10 to the negative 2 meters times 10 to the negative 2 meters times 10 to the negative 2 meters, and so you multiply, that will give you the value of 1 times 10 to the negative 6. 1 decimeter cube, on the other hand, decimeter is nothing but 10 centimeters, so that is 1 times 10 to the negative 1 meters cube, which is nothing but equal to 1 times 10 to the negative 3 meter cube. Whenever we measure volumes of solids, we use meter cubes. On the other hand, when we want to measure the volumes of liquids or gases, we use the term liters. 1 liter is really equal to 1000 milliliters, and that 1000 milliliters is equivalent to 1000 centimeter cube. So in other words, 1 milliliter is equal to 1 centimeter cube. Really, that 1 liter is 1 decimeter cube. So it is important that you learn these relationships. Yet another derived quantity that we will come across is density. The density is measured in terms of kilograms per meter cube. So in other words, by definition, it is the amount of substance present in a unit volume is nothing but density. For common uses, we always define density as gram per centimeter cube or gram per milliliter. Remember, 1 centimeter cube and 1 milliliter are the same. In SI units, we express that as 1000 grams per meter cube or 1 kilogram per meter cube. So density is really mass over volume, and so therefore a simple relationship you must remember is D is equal to M over V. So let's take an example and solve. A piece of platinum metal with a density of 21.5 grams per centimeter cube has a volume of 4.49 centimeter cube. What is its mass? So remember the relationship, density is equal to mass over volume. We can rewrite this: mass is equal to density times volume, or if you want volume, then volume is equal to mass over density. So we can make these modifications depending on which characteristic we are trying to determine. So density is equal to mass over volume. We need to find mass, so therefore mass is equal to density times volume. We know that the density is given as 21.5 grams per centimeter cube and the volume is 4.49 centimeter cube, and we can cancel the centimeter cube units, they get cancelled, and the mass is 96.5 grams. So this way you can determine the density. Density of substances are very unique. Take for example air. The density of air is 0.001 gram per centimeter cube. That means it's very small, isn't it? There are very fewer particles in a centimeter cube. Now take for example ethanol. You will see that the density is 0.79 gram per centimeter cube. Water on the other hand is 1 gram per centimeter cube. Mercury, you can say 13.6. Table salt 2.2, iron 7.9, gold has a density of 19.3, osmium on the other hand has a density of 22.6. So each substance has a unique density. So therefore you can utilize density to identify substances. Density of substances is dependent on temperature. Take for example water. water's density at about 3.98 degrees Celsius or 4 degrees Celsius is 1 gram per centimeter cube or 1 gram per milliliter. You decrease the temperature further, the density decreases. You increase the temperature further, the density decreases as well. Now, water is a unique substance where both decreasing the temperature and increasing the temperature, the densities decrease. For most substances, as you decrease the temperature, density increases. Increase the temperature, density decreases. What happens when you increase or decrease temperatures? When you increase the temperature, a solid turns into a liquid. When you further increase the temperature, the liquid turns into a gas. When you do this, the distance between the particles change, so that means the number of particles present in any given unit volume changes, and that's what leads to changes in density. With that, let's see if we can do another problem related to measurements. A piece of metal ore weighs 8.25 grams. When a student places it into a container of water, the liquid level raises from 21.25 milliliters to 26.47 milliliters. What is the density of the ore? What is the density of the ore? Now, these kinds of problems you will encounter in the exams, quizzes, homework, reading assignments, and so on. So, therefore, it is best to practice them. So, let's see how to do this example. So, we need to find the volume of the ore. Volume of the ore is really nothing but volume final minus volume initial, which is nothing but equal to 26.47 minus 21.25 milliliters, and the difference is equal to 5.22 milliliters. Now, the mass is already given. Mass is equal to 8.25 grams. Remember, density is equal to mass over volume. That is equal to 8.25 grams. Divide that by 5.22 milliliters. And if you did that division, you get 1.58 grams per milliliter. So therefore, the density of the metal ore is 1.58 grams per milliliter. Let's go back to the list and see which is the correct answer. Correct answer happens to be 1.58 grams per milliliter, and therefore C is the correct answer. Yet another measurement that you encounter is measurement of temperatures. Temperature in SI units is measured in terms of kelvins. Commonly, we measure temperatures either in degrees Celsius or in Fahrenheit, and let's see how they compare in terms of magnitude. Kelvin temperature is considered the absolute scale. So, at zero kelvins, there is absolutely no movement of the particles. So that means the kinetic energy of the particles is zero. So that means the temperature is going to be zero. That's the absolute zero. Anything above that, there is going to be kinetic energy in the particles, and there will be temperature associated with it. In degrees Celsius, at 0 degrees Celsius, water freezes. If you would extrapolate that to kelvins, it is 273 kelvins. Yet another way to measure temperature is using Fahrenheit scale. In the Fahrenheit scale, that 0 is really equal to 32 degrees Fahrenheit. At 25 degrees Celsius, which is room temperature, Kelvin scale is temperature is going to be 298. So you simply take 273, add 25 to that, it becomes 298. Now the room temperature is equal to 77 degrees Fahrenheit. The body temperature is 37 degrees Celsius, 98.6 degrees Fahrenheit, or 310 kelvins. Notice that the water boils at 100 degrees Celsius. In the Fahrenheit scale, it boils at 212 degrees Fahrenheit, and that is equivalent to 373 degrees, rather 373 kelvins. So that means the degree, 1 degree C is equivalent to 1 Kelvin. The magnitude, not 1 degree C equal to 1 degree Kelvin, I take that back. It is really the magnitude of 1 degree C is same as 1 Kelvin. So therefore, if you want to calculate Kelvin temperature, kelvins is equal to degrees centigrade plus 273.15. If you want to convert, so in other words, notice that 273 is 0 degrees Celsius, 373 is 100 degrees Celsius. If you want to convert temperatures to Fahrenheit, the Fahrenheit degrees is equal to 9 divided by 5 times degree C plus 32. So how do you come to this conclusion? This conclusion is based on 1 degree C magnitude, 1 degree magnitude is equivalent to 1.8 degrees magnitude in the Fahrenheit scale. So 9 divided by 5 is nothing but 1.8. So you times that with degree C plus 32, then you get your Fahrenheit temperatures. So notice 32 degrees Fahrenheit is going to be 0 degree C if you used this formula. 100 degrees C is going to be 212 degrees Fahrenheit if you use this formula. So I suggest you remember these equations. So let's take an example and see if we can make the conversions. Convert 172.9 degrees C to degrees Celsius. Remember the conversions and the formulas. If you want to convert to degrees Fahrenheit, we know the formula is 9 divided by 5 times degrees C plus 32. So we can rearrange this to convert from degrees Fahrenheit to Celsius. So let's move 32 to the other side. That means it becomes degree Fahrenheit minus 32 equal to 9 by 5 times degrees C. Now keep C on this and you move this to the other side, so that means you have to divide this by that factor. If you did, degree C will become equal to 5 by 9 times degree Fahrenheit minus 32. So 9 by 5 times degree Fahrenheit minus 32. You have 172 times 5 divided by 9, which is 0.555 times, rather subtract these two and then multiply by that, you get 78.3 degrees Celsius. So you want to be able to make these kinds of conversions. We will make more of these conversions in problem solving sessions as well as in dimensional analysis later.